You can probably put that thing in one corner of the house and put a light bulb with another one facing directly across the room, and when you're going to turn that one, that light bulb over there is going to light up, and I guarantee you it will work. Find out, oh, literally, that's way more power in that with this energy than we can get it from the wall, because we'll get more. The only reason I'm doing all that is because I'm waiting for glass for my cell, which I blew up myself, and I'm waiting still for the wire for the generator. Hey guys, what I'm going to do is I want to do some tests, and I want to show you something how a induction stove work on the plate. And the factor is you're able to pull a massive amount of energy and transferable to a different coil, but without the sign of electrons. Same thing again of all my equipment. When I run my generator, I have a three-dimensional field, which I show with a tri-field meter, electronic tri-field meter. I still have the same field because I'm using a sample coil of wire. Very simple. It's 16 gauge speaker wire, and I didn't take the spool apart. I just strap it together. It's 50-foot spool. I just strap it with zip straps, rearrange the wires. I connect one wire from the inside to the outside, so I have a continuous 100-foot long spool of wire. Okay, nothing fancy. And I'll be using amp meter in the line. I got 2 amp meter. I got another one on that board. I'm also going to be using an old-fashioned voltmeter. That one's 1,000 volts, because the electronic device I have won't read the volt coming out of the coil. So I mean, like, this it doesn't have an electron, so that's the reason this guy cannot read. So anyway, I'm going to reset the camera here. I'm going to show you a little bit of example what's going on in the coil and a little bit of reaction. So I'm going to turn you off for a minute, and I'm going to reshoot here so I'm ready to go. So you won't see my face, you will only see the reaction. Alright, so I got the ring of iron. I need an iron ring to literally trigger the system, because the board is built with a sensor built into the board who's sending a signal back and forth to see if there's any iron there. So now I get the iron ring, so I'm going to activate the stove. So I'm going to turn it on, and the bar comes in, and oops, wrong again. Okay, we're having a problem. It's fussy sometimes. There we go. Now we got the thing going. Now I'm going to bring that back here so we have a view, and I'm just going to bring the coil inside. Now as you see, I'm doing 3 amp on the resistance directly on the meter. So my coil is putting 3 amps. Alright, so that's my maximum. Now we're going to turn that off. Now I'm going to turn you off a little bit. I'm going to do the volt, but I have to reset for the volt, so I'll be right back. We're back again here. So now I reset. I put the junction with the voltmeter. So when I set the voltmeter at 1,000 volts, and you have to read the red mark. So it says, like, it start at 1, 2, 4, 6, 8 Those are 100 volt. 4 is 400 volt, 6 is 600 volt, 8 and 10 is 1000. All right, so let's see. We'll start the stove again. Okay, you see 1000 watt goes in there apparently. Now okay, and let's see. Right, so I'm 650 volts. I'm pretty sure people can see all that here. That's 650 volt roughly. That's what this coil produce. All right, so it's just 2 lead going directly to the voltmeter. All right, don't try to use a digital meter. They do not see the volt, because this volt does not carry any electrons. So I'm going to reset again to give you another demonstration. Alright guys, I'm going to give you another demo here. This is two 500 watt halogen tube which I connected in series. Okay, now I'm going to connect it directly to the wall, and we'll see how bright it is and how much amperage is taking directly from the wall. Now that's two 500 hook up in series. See, our power cannot take series. Everything you put series, it diminish, right? It won't like series. It just doesn't like it. So you have about 25% of the luminant from, and you're only eating 2.4 amp at the meter here in the line. So at that point in time, I'm gonna do something. I'm gonna disconnect this here, right? And we know this coil here make 3 amps at 650 volt, right? So you have to understand 120 volt per bulb, right? That's 240 will be extracted from the 600 volt total. Okay, so now we're gonna rehook up directly to the coil. Sorry, I'm turning my back, but I gotta do things. And we're gonna rearrange here how things is gonna work. And I wonder, the camera is far away because I want you to see the difference in light. So now I'm gonna take my iron rings to activate the induction stove. Turn my induction stove on. That's my power supply with an amp meter. So let's see. Let's try to get some light going on. Oh, come on, there we go. .4 amp, and I got 3 times the lumen. And that's in series from the coil. Okay. Now if I just hook it up to a single light, which would be like this here, so one will be dismantled. Then I got my 500 watts LED, but see what's happening, you don't see the full spectrum here. I am in the spectrum, but the camera right now is compensating for the extra light, but this thing is blinding. Now, I'm going to turn that off again. This ring heats up when you don't, so you want to keep it cool, so I don't want to burn myself up. Now we're going to rearrange this here. Be careful when you handle that. Now I'm going to bring him good old-fashioned 300 watt, and here's the box. .300 watts clear light bulb. We call it the useless light bulb because they don't throw a whole lot of light for 300 watts. So we'll see what that one can throw. And we'll hook it up directly to the coil, and the coil goes through the amp meter again. So we'll see what kind of power we have. Now we're back to the ring. Turn the stove on. Set temperature is going. Now this bulb is bright as hell, like, you know, you can't look at it, and the temperature of this bulb is so hot inside that bulb right now is actually burning the glue they use or the cement what they use for bonding the glass with the aluminum caps for the screw things. That's how hot it is. I mean, that thing is just throwing just as much heat as a 15 to 1800 watt heater. So I mean, it's just nasty, nasty hot. So what I do, I put a shade on it, but you can tell the difference. Now I'm going to disconnect this. I'm going to disconnect the coil. I'm going to reconnect the amp meter to the light bulb and to the wall, directly to the wall. Now here it is, I'm plugging that to the wall, and we'll see the difference in brightness. I can look at it no problem. It doesn't hurt my eyes or nothing. And soon you connect it to the other one, and then the amp meter is exactly at the same thing, 2.4 amp to run at 300 watts. Now remember, before I was running a 500 amp, a 500 watt, and also another 500 watts for 2.4 amps. It seemed to be the amps and the voltage, which, since they have no electrons, they have way more power. I mean, the coil, if you on the top of the stove and you touch the end of the coil, you will get burned. You will get hit with a hell of a voltage, and you have 3 amp. Believe me, it burned. I got 2 marks. Experience. So, but there's no iron here, right? It's just a straight spool of wire, right? So when I'm trying to test what is going on, I mean, right now this bulb, through this coil, I can bring the temperature of this bulb to 8 above my meter, which is, let's see if you can see clearly here. It's 800 and some degrees, 842 degrees Fahrenheit, and I overload. I go over that and that bulb there when I'm running through the coil. So we're having a massive reaction if you take the system of induction. And to me, the system of induction is very simple. I got one. I burned one already because I did a stupid thing to it. But anyway, it's good because I know I got spare parts. First thing, you have to have a control panel, which is half of this board, right? That's your control panel. And then you have your transmission board, which is underneath here, right? You got your electronic, you got your DC output cap, and you have, you know, where the coil will mount to. Now the coil is a Tesla communication coil. Very simple, very efficient, and you move energy without electrons. Remember, Tesla was saying you have no loss between point A to point B for transferring the equal amount of energy. So this means what you're sending for one transmitter, the other receiver will have no loss in it. It will be the same numbers of volts and energy you're sending. So you have no loss since you're not using electrons. This is Tesla here. Tesla on its prime. I mean, anybody who know about Tesla, that's exactly what that is, right? And what they do, they build up instead of using mechanical device to energize this coil, they use a board. So I'm not too sure because they're using woodpecker effect in here, because when they're looking for the iron on the top of that, you know, I'm getting a woodpecker effect every half second for 5 seconds. You get half a second on, half a second off, and then it goes back to default, or you know, they don't show any iron on the board. So to do a woodpecker effect, you know, to go and send, this means they're sending a bing. The coil sending a bing out, see if it's going to bounce off to any iron electrons and come back to it. And then it tells you, oh yeah, I got an iron, I got a cast iron or any type of iron, which is iron, not aluminum. Okay, now I can start transmitting the resonance, because everything runs on resonance here. This meter, which is called the tri-field magnetic field meter, which is not magnetic field, it's goddamn resonance. We find that earlier, right? This guy go crazy. I mean, literally goes crazy. I mean, we should be all dead, you know, when you turn one of those things on. Never mind what I'm doing, just the hot plate on. This guy say we'll all die, right? Because it's a transmitter of resonance, and the resonance is on frequency. And what is very interesting is 22 kilohertz, 22,000 hertz a second, which is like interesting because all your three-phase motor drive, induction motor drive runs on 22K. Your washing machine motor, 22K. Your RC motor, all brushless RC motor, 22K. All the controller runs on 22K. Like, you know, everything is, you know, and communication or transmission is 22K. So we have a pattern here going on with a 22K, which is really important for the iron, because that's what the iron uses, 22K. That's the best resonance for the iron molecule. So that's why everything is running literally on 22K. And they slash it. Right now, what's coming out of here, I don't know why I can get the 22K hertz out of it through the instrument, but I cannot get the 60 hertz. Now I test that the output, and it's really easy to test that. If the output has got a 60 hertz, when you can't find a 60 hertz with just a small induction motor, a little fan motor, right? Nothing serious, just a tiny little guy. And what I did, well, since I can light up bulb till you go blind, and I got 600 volts at 3 amp, I said if it gets 60 hertz is in there, that's going to run. I connected, it doesn't run. It doesn't have the 60 hertz in it for making that thing run. So, I mean, it's, at that point in time, is the research, I mean, it's a lot of power coming out of it. You can multiply the power out as many times you want, because now you're in communication form. If you modify this coil, because if you see, all the coil is made, it's not a single core wire, it's a multi-core wire, right? And it's got probably about, I would say, maybe 30 to 40 braid on each wire, twisted, right? So that controlled, that buff, that's what controlled the communication, how far the communication is going to go up this coil, right? Well, by putting multi-braid, the communication is really low. It cannot project very far because it's bound inside all those windings. So they control the distance. So you only had about an inch of getting induction or transmission, right? So by modifying the board a little bit, by modifying the transmitter antenna, you can pretty well put out a massive amount of power here, out of it from what you're taking. Now the board takes 5.5 to 6 amp just to energize that board. and then every time you put something on it, all depends what it is, it will draw more amp. So the volume of iron receiving the transmission and heating up suddenly consume more amp out of, they start pulling out from this coil and to the pan. So I did it with this here and that, and maximum I can get is 2 amp, 2 amp. I mean 2.4 amp, 2.4 amp on both sides. They work perfectly equal. So that's what set it. And then the temperature, when you control, you're thinking about working at 2.5 amp of energy and producing over 800 degree Fahrenheit of temperature and melting the inside of a bulb, internally burning the bulb, but not the element. Now I'm going to show you a bulb where that one there is fairly new. I've just been doing some tests with a bulb, and as you can see, the bulb is black on the inside, right? That's mean it got really hot. Matter of fact, you can see the inside is not pretty anymore. It's black. It's all burned up. It used to be a nice light caramel color inside here. Now you can see the bottom, where the smoke, when it's burning, it covers up the bottom, so it's all fuzzy. But the element is like brand new. It's like it's never been turned on. It's not this color or nothing, right? And that's really interesting. Tungsten change color when they heat up. Now I put yesterday I tried. I'm gonna keep that one out. I tried another bulb which is 150 watt, clear, just to see what it would happen, right? Oh, that's that. That's 250. No, wrong bulb. A 200 watt bulb. And look what happened. I don't know if you can see this, really hard to see. But the two rods underneath the tungsten, oh there you go, you can see it. The two rods bringing the power to the tungsten spring, both blow up at the same time. Look at it disconnect and melt itself to a nice little ball on each end of it. That's 200 watt bulb. And you can see there the inside the bulb, a nice, look how nice and yellow it is when it's not overheated. The other one is black. So for burning something like this, those are, I believe, either tungsten rod, but I'm not tungsten rod, they're probably stainless steel rod inside that bulb. But then again, I'm just assuming there. But as you can see, this one is still attached because the rod longer. Because the delivery, the resistance on each rod was much greater on this one here than this one, so that one could not take it. That's why they both blow at the same time, because the energy is equal. So it's really interesting how that thing worked. This bulb still works, by the way, but like, you know, I want to save it, you know, to see, because we have some black inside, and they thought it was building, was actually create, the heat was so high I was actually create carbon. But when I find out I'm burning the bottom one, I was smoking, then that theory went to hell. So, but it's still interesting what's going on with that bulb. Now, after doing everything else, what I'm going to do is next time I'm going to do is I bought some wire, which is heavier. That is 12 gauge wire, single core. I will make some proper Tesla coil, the pancake coil, the proper one, and I'm going to do the proper coil on it and see with the proper coil with a full size. Right now, look, I'm only pick up a very tiny little bit. See how much I'm missing? I mean, the inside is okay, but the outside I'm missing almost half of the coil. right? So I'm just gonna redo some wiring and change my coils to that wire and do a double one and see what I got and see what my potential is and what is going to be drawing from the wall to that in the reverse, you know, see if I'm gaining or losing. But in heat and light and spectrum, when you get a 300 watt bulb will put out the spectrum of a 1000 watt bulb and the temperature past the 1000 watt bulb with 2.5 amp or 2.4 amp, you got to scratch your head to see what the crap is going on there, because it's got no electrons. That stuff work exactly like my generator with no iron and my small pump there and the bench. It doesn't produce electrons. So why are we, if it's more efficient without electron, 2.5 amp to 2.4 amp can do way more than what is on the wall coming out with the electrons. Maybe we should change our system, because the way I see this thing here, if you balance everything right, you can actually cascade those coils and you can actually produce a shitload more, like when we're talking about hundreds of times over what you put in, because now you're moving everything through a communication system. I mean, it's easy to move stuff through a communication system when you don't have electron. You don't have to worry about, you know, the heating and all that stuff, because you're removing the electron. That ring get hot here. When I energize and I move the ring away, that thing doesn't get hot, you know, because I can run the light with another ring. I just have to use the ring to get this thing started. But that doesn't get hot when the ring is out of there and it's still energized, right? So I mean, like, you know, it's a very interesting system, which some people probably think they can make something really quickly out of it. It's not happening, okay? I mean, I broke down this thing. I got, like I said, how much I broke down those things, right? I take it apart. I buy them and take it apart, right? And see what the hell I can do with it, right? So I mean, like, you know, I wouldn't know, like, you know, if I were just talking to you because that box is closed, and I would be a fucking babbling idiot. But I take those fuck apart, I blow them up, I try to fix them, find out what is wrong with them when I blow it up. What is the weakest point? That's what I do, right? But if someone would be deep enough in electronic to be able to either rearrange this board or build a board very similar to that, just with a transmission system, and be on and off, that would be the cat's ass, because then we can eliminate a lot of the function, right? I mean, it's not a function, therefore rising the temperature, it goes from 300 watts to 1800 watts. That's a lot of function in the board, right? So I mean, we can eliminate all that and just go with the function, because I'm not getting any more of that coil here, right, at 1000 than 1800. So I mean, like, obviously I need at 700 watts, I lose about 40%. At 500 watt, it shuts down. It won't hold on to it. So 1000 watt is the magical numbers. And 1000 watt, everything works. Nothing really gets hot. Get a little warm, but not hot at all. And I run those things for an hour. So I know I didn't melt the wire yet. I melt a lot of other stuff, but not the wire. So I mean, this technology has been suppressed, and that's directly, this is the closest thing you'll ever find directly the function of Tesla. Actually, if you take that off and put a solid core wire here, you can probably put that thing in one corner of the house and put a light bulb with another one facing directly across the room, and when you're going to turn that one, that light bulb over there is going to light up, and I guarantee you it will work, because the way they damp that up so the energy doesn't go any further away, so they want to remain everything nice and tight. But this is what Tesla, I mean, look at this, and look at Tesla's book when he's sitting beside his big coil is about 10 foot across. That was similar to that, isn't it? Right? I mean, like, you know, we're talking about things like, you know, a wire, wraps of wires. And that's the only recoil he doesn't talk much about. He shows it, but it's not a whole lot of information on those coils and how it's connected and how it works and how should it be working and whatever. It's like, you know, that's the biggest secret, is how this coil works. But right now, I'm getting a pretty good damn idea with it because I've been playing it. I mean, that's not a Tesla coil, that's just a spool of wire. But on the top of it, he picks it up and he's got no iron. So, anyway, just to let you know what's going on. So, yeah, that's it's interesting. The lie we've been living and the bullshit, you know, people, you know, the corporation and the government don't want to tell you. I mean, like, you know, it's just crazy. The only reason I'm doing all that is because I'm waiting for glass for myself, which I blew up myself, and I'm waiting still for the wire for the generator. So we have lots of worrying about it and stuff like this. So instead of me sitting in my butt and doing nothing and watching the rain down, I go out and do stuff. I go out and pick up some stuff. Let's try that and let's try this and do some research and find out. Oh, literally, that's way more power in that with this energy than we can get it from the wall, because we get more heat, and everything is calculated on watts and heat. That's the calculation the scientists like to have, is heat. How much heat can you generate? How much amp do you draw to do this? That gives you your percentage, right? Wow. I mean, I just show you the difference. It's just amazing, you know. And I'll show you again. I'll plug this one in directly to the wall. Right? That's what we get. Now we'll change that to the coil. Just a last little check here. I'll switch that to the coil, and we'll see right away how bright this whole thing is. Now I'm going to remove you will see me removing I'll energize it and remove the iron out of that. It's got to be slick. You don't see, without the ring, because the ring is taking power. Now without the ring, I'm making 2.8 amp, and that's bright. I mean, like, look at this thing. I mean, it's so. If I take that can out right now, let me see. Yeah, I should take the can out just to give you. You can't look at that bulb. I can't, and I can look straight at the sun. Whew. And this here doesn't get hot. Absolutely no heat in here. And that's 1000 watt. So that's a lot of lumen. I can grow. I got a 300 watt bulb with this technology. It can actually grow food. I bet I'm throwing better lumen on this here than the actual grow bulb. Another thing, we should be looking into it. Design an energy for, and you can buy a regular light bulb to grow. The energy is the one to control the spectrum of the bulb, not the bulb controlling the spectrum of the power. You know, you should be reflecting what you put into it. I mean, it's so hot. The white thing where you twist the bulb is burning. I have to put another steel plate, a pan underneath, because that's hard glass, that's tempered glass, for stopping the heat. It gets so hot through the glass, it's burning my carpet underneath, so I had to raise it up with another cookie sheet, so I get more space underneath. I mean, this is ridiculous. And all this power, look at the lead. Nothing get hot. I'm pushing almost 3 amp. That little lead here, those are the smallest bloody jumper. They're only good for 1/4 of an amp for like maybe 5 minutes. They get hot right away with 1/4 of an amp because it's barely nothing in there. It's 3 little strain of wire. I'm pushing up to almost 2.8 amp. The heat seems to concentrate at the delivery. at the element, not in the wire. I can run that all day long with those tiny little lead and they won't get hot. Right? The same thing. This is a vacuum spark gap, right? Those same little lead. I can bring the temperature, those tungsten rod, the 1/8 of an inch, they go extremely red, like I'm talking white red. And look, I even create the color, the blue color inside from dropping the temperature, dropping the volume of vacuum rapidly, and it brought the air back into it and create cobalt inside the glass just from the atmosphere change. But I use those tiny little clips, those little lead, to bring the power of a 1/8 of an inch tungsten steel and bring the temperature beyond, you know, almost to the point of melting the glass. So this energy concentrated in the end where the energy is being demanded, not into the wire like the rest of our 120 and 240. The heat goes down the wire all the way up to your breaker box, and then click the breaker when it's too hot. This doesn't do that. It doesn't go back. It does the function in the end where it's supposed to happen. So I'm pretty sure you're going to find out interesting, but you know, to me it's very interesting because it totally functions a totally different way. Like, you know, completely beside any explanation of electricity, the way it worked, the way it's calculated, the word they're using, everything else, you know, doesn't fall into that categories. And this category has been suppressed for a long time, but look, they have it, hide it in equipment, appliances, stove, hot plate, you name it. Where no one would look beside, oh, the expert, right? So I mean, like, you know, I don't know, call me crazy if you want, but this is real power. I mean, this is really heat. I'm heating up my garage right now. If you run that thing for 15 minutes, you know, I have to open the door, it's too hot. I mean, we boil water on top of it with a pan. You know, you can cook over that here right now. It's a 300-watt stove where you can cook. So figure it out. You go ahead and find me a 300-watt stove, which you know, you literally can cook in it. But that's the way it goes. All right, guys. No heat. See, so you need to take that off. Room almost just a little bit above room temperature. But I'm pushing up 3 amp. That thing is now heating up, right? And you cannot start it back up here with that without having you know, electrons. And that's what the board should be modified. So when you turn it on, it just goes on, right? But you know, so I mean, like, I don't know what to say, but it's just a question of studying this here, a little bit of research on here. Will, you know, I'm to the point now. I know with a generator, when I get the right wire, I can bring up my voltage. But more and more, I am on the right track with the chopper. You want to create a high resonance voltage, very high. That's your potential, and then you chop it up to 60 hertz and dump it into the transformer. I mean, and then the magic happened in the transformer. It modified everything out back into this stupid juice we're using. I mean, the world should be running a new type of energy, not the old type. But we're all the same. We're all tied up to the hip with that type of energy. So we're gonna have to come up to replace the supplier, so we have our own supply, you know. And then down the road we can literally change to a new type of energy. As far as I'm concerned, I think that's very right. The energy can be transmitted through the house for all your equipment with no wiring, and that would be a nice thing. So we don't have to have wiring to wire. The house became a grid, and you're getting sick inside and whatever, right? So anyway, it says about it. So hopefully you guys gonna watch that. You're gonna enjoy it. I'm just gonna roll myself a fat one and back into doing research. Catch you later, guys.